Hi, good morning, and welcome to Machine Money, Empowering Devices with Wallets. The talk today will be 45 minutes, followed by a 15-minute Q&A. So if you have any questions, please use the QA panel at the bottom of your screen. You can also use the chat to talk, but ask your questions in the Q&A panel. So our speaker today is Louis Freiberg. He is the Director of Ecosystem at the IOTA Foundation, where he works with governments, corporations, and private individuals. His goal is to bridge the gap between the distributed ledger and the industries that it can impact. Thank you so much for being here, Louis.
Thanks for having me. Over the next kind of 45 minutes, I'll quickly run everyone through my presentation. We'll talk about this concept of machine money, what that means, how it works, why we would want such a thing, and then talk a little bit about the contest that we're running with Hackster. To give you a bit of context about what machine money is, we first need to understand what's happening kind of around it. So by 2025, it's expected that there will be 100 billion devices connected to the internet. So, each of these devices, collecting information, sharing that amongst each other, and producing a whole torrent of data that needs to be, collected and understood. So these connected devices are referred to as the Internet of Things. And so this is really the digitalization of the physical world, where we have, lamps on street corners or, ATM machines and various other devices that are now becoming more and more connected and sharing this information. So there's going to be a massive amount of devices, roughly about 12 per man, woman, and child, that'll be, sensing, communicating, and sending data around the place. And so from this will evolve an economy of things. And so not just having these devices connected and talking with each other, but also as a place for these machines to interact with each other, offer and pay for services in a reliable and cheap way. And so this is really what we're trying to achieve with the IOTA project. We want to enable this economy of things where devices can interact with each other and do these type of things, value and data transfer. But it's a bit hard to have a system or an economy like that when you don't have any money. And so you'd say, well, money exists, but money at the moment only exists for humans. So it doesn't exist for machines. So when you think about money's been around for a very, very long time. We can use it to pay for the groceries and hand cash or, physical notes over to the merchant, and you'll be able to pay for items and goods. But when the internet came around, what we did is we digitized that idea, digitized that concept, but we didn't make it truly digital. And so what we have now, when you look at your banking app or anything like that, is just a representation of, that old way of looking at money, the cash and transfers like that. So if you wanted to send money to somebody, on the other side of the world that wasn't, directly in front of you, you'd need to use a bank or an intermediary service to transfer those funds. So you can't send money to another person without having somebody in between. And this is quite challenging when you think about the way in which we interact with each other. So banks, so then when you look at it in the context of machines, it becomes a much larger problem where you need to rely on another institution, a bank or an intermediary, to be able to provide the software to be able to integrate machines, to integrate their payment services into these machines. And if you've ever looked at any of these banking APIs, there's very few of them. And the ones that are available, they're quite limited in what they can do. And usually you have to pay big license fees and things to interact with them. So in the current state, it's very, very hard for us to integrate machines into kind of the monetary system and have them interact and send money between each other. And so this problem is a symptom of the age, the complexity, and how expensive the current payment systems are. So there's trillions and trillions of dollars transferred each year using a language called COBOL. And so this language was developed in the 50s. So that's like 70 years ago, if I can count properly. But it's still widely used by banks today. So not saying that there's anything wrong with the language specifically, but I would hope that in 70 years of progress, since computers were invented, that we'd be able to come up with a better language to, have safety, speed and security around our financial system. And so the problem that a lot of people are facing, a lot of these banks are facing, is that the infrastructure that they've built, the software, the systems, the internet connections between the different systems, the knowledge is leaving, in the sense that many of the programmers who built these systems are retiring because the language and the systems are so old. So on top of that, when you have these systems, they're quite complex. So in order to do a simple, credit card transfer, if that's online or in person, you need to have 7 different actors to be able to do this transfer. You need to have, the person who has the card and their money. You need to have the merchant who wants to receive that. You need to have the acquirer, the bank that it relates to that acquirer, the network like MasterCard, Visa, or American Express. And then on the other side, you need the card issuer and the bank that's associated with that. So there's so many different moving parts when you need to have a transfer happen. It's quite complex. And this is because of the way in which technology has progressed and systems were built upon systems to allow for these transfers to happen. And then when you have these complex systems with multiple different actors, each of these actors needs to get paid. So in order for a credit card transfer to work, you need to have these 7 entities, providing a service, and each one of them will take a small percentage of that. And so, the standard rate is usually 30 cents for each transaction and 3% on the rest of it. And this becomes a bit of an issue when you want to transfer small amounts of funds. So like, when you go to a convenience store and you try and pay for something that's, under $1, usually they won't accept cards. Usually the limit's like $5 or $10 because the transfer fee is actually quite large and it eats into the amount of money that they actually get from that sale. So what we have is a large, old, complex system that is this kind of digitized old money, and you can see that there are some issues with it. You see that we need to figure out a way in which we can create a new system that will allow for better transfers for humans, so we can transfer money in a much quicker, much cheaper way. But also, if we ever want to have these 100 billion devices connected to each other, transferring value and data, we need to figure out a new way to think about money. And so it's not only people like us at the IOTA Foundation and people in the distributed ledger space who are thinking about these things, but also central bankers and various other groups are thinking, well, maybe it's time to replace that infrastructure that we've had for so long. And so I put forward the concept of machine money. So it's a money that's built for the digital world and built for the devices within it. So it has a number of different qualities. The main one being that it's easy to integrate, easy to use with devices. It's programmable, so you can have applications being built on top of these, being able to receive and send funds without needing to interact with a third party, needing to rely on their infrastructure. The devices themselves can, in effect, be their own bank and transfer funds amongst themselves. It needs to be cheap. So when you have these devices interacting, you're not going to have, a street lamp who's connected and providing information about the number of cars passing and how light it is outside, whether it needs to turn on or not. That device isn't going to be paying 30 cents for each transaction it does to purchase power, or for the people purchasing how many cars are going down the road, the information for that, they're not going to be spending large amounts of money on it. So we need a way in which we can transfer funds that is cheap and allows for single cent transactions or even smaller than that. It needs to be resilient, so you need to be able to have these systems operate in a fashion that doesn't go down. You can imagine the chaos that when everything is connected. If the internet goes down or the networks that these devices rely on, then everything stops. And this is quite a bad scenario, and something that actually occurred in Australia recently, where one of the telco providers, their internet went down, and basically all of the payment terminals in Australia had troubles for an afternoon. And that was a small example where, you know, country of 23 million, and it was only an afternoon, but the estimated loss from that was $100 million in revenue. So when you start to think about how everything's going to get more connected, the impact will be much greater. So we need to think about ways in which we can have systems that don't rely on a single central party, but ones that can be spread amongst various different ones and be resilient against, you know, issues like that. And we also need to standardize it. So when you have these devices interacting with each other and sending value, they need to know what language they're speaking. They need to know how to request things and how to pay for things as well. And so this sounds very, very nice, and you know, this system is something that would be ideal if we could have it. And you're probably thinking, why don't we have this right now? You know, why is there all of this old infrastructure that exists within the banks and the systems that are put in place? It's because the technology that enables it is quite new. So this type of money, this type of machine money, is enabled by distributed ledgers. And so these are like protocols in which a group of actors can come together and have an understanding of a ledger state. So what this means is that everyone knows who has what amount of money and is able to agree on that result. And so this allows for immutable value transfer. So people can send tokens from one person to the other without having to interact with any other intermediaries. They can just publish information to this network, and then the person receiving the funds can just read that they have received them. And so this technology is quite new. It's only been around for about 10 years. And it enables something that wasn't possible before, which is value transfer in a system that doesn't rely on a single actor like a bank or something like that. And so why should we care about this, right? Like, it sounds all very very futuristic that we have these devices being able to send and receive funds where they currently can't. So why would this change the world in which we live in, and how will it change it? So I'm going to give you a few examples of scenarios and ways in which machines being able to transfer value themselves will be able to change the way we interact. So one of the examples that comes up quite a lot when you talk about integrating, value transfer into machines is energy. So energy is an interesting use case where you're able to transfer it to different devices, and there has to be kind of a machine on either end to accept it and use it. So you can imagine a scenario in the future where instead of purchasing power from the coal power plant or the gas power plant down the road, you use renewables in order to power your home or something like that. But I think I read a statistic somewhere that says that 15 times the amount of energy that you require in your household each day falls on your rooftop. So when you have these houses being built with new solar panel installations on their roof, they're generating more energy than they need. And that's usually throughout the middle of the day. So what these devices can do, rather than either turn off the solar panel to stop receiving energy, what they can do is they can offer it for sale back to the grid or back to those neighbors around them. And so having a smart meter or a smart photovoltaic cell in your home and allowing it to offer energy to your neighbors and to the grid itself can be a way in which your home can contribute renewable energies back to those around you, but also make money from that. Because at present you're locked into one provider. You have to, if you have photovoltaic cells on your roof, you have to accept the rate that is being given to you by the grid provider if you want to put any energy back in. And so what you can do is you can have the smart meter working for you to be able to sell it at the highest price to those that want it. And so instead of having to power everything individually using the standard grid architecture, you can have all of these individual generators on the grid being able to share energy, charging vehicles, turning on street lamps, things like that, and not have to rely on fossil fuels and those in the future. Another good example is looking at mobility. So when you think about, vehicles, most people these days have a combustion engine vehicle, but in the future, a lot of these cars will be electric. And so these cars, even the most recent models will have a computer on board. So this computer will be able to control, the stereo, the locking and unlocking the engine, all of those different things. But what happens if we're able to introduce a wallet into it, give it the ability to do value transfer? So how will this device that is able, is now starting to be able to self-drive and do all these different things, how will it interact with the world around it? And so there's this video that I'd like to show you from a company called grid operator in the Netherlands called ELAD-NL. And so they built an IOTA charging station, and they made a video about it. So I'm just going to quickly I'm going to quickly check my screen sharing to make sure that I can share sound, and then I'll start the video.
In tomorrow's world, we'll all drive electric cars. And by using solar panels and windmills, we'll generate our own renewable energy. With smart charging, we'll make sure we use 100% of what we generate. This means that all kinds of devices have to start communicating with each other, and there'll be a need to make or receive payments for their services. That may sound complicated, but in practice, people won't even notice the devices are at work. Let's say you work from home today. Your electric car is parked outside and is charged by the overcapacity from the solar panels on the nearby school. In the evening, the energy stored in your car will now power the lights in your house. And together with other nearby cars, you might even be providing the power for a concert in the local park. Throughout the night, windmills located just outside the city will refill the car batteries. So in the morning, you leave for work fully charged on renewable energy. To successfully automate this whole process, both data and value transactions have to be calculated for every exchange between these devices. In the future, these will increase exponentially. The old approach of registering every electricity exchange centrally and then paying through the bank afterwards is not particularly appropriate for these kinds of microtransactions. Luckily, there's a new kid on the block: cryptocurrencies. These are way more suitable thanks to the underlying distributed ledger technology, or more simply, DLT. It is secure, transparent, and peer-to-peer, and supports both data and value transactions. The best-known DLT application is the Bitcoin, but because of limitations in its technology, it's not really suitable either. But hang on, recently, better alternatives have become available. One of them, IOTA, makes use of the Tangle, a new kind of technology, which is ideal for these microtransactions. It is fast and costs close to nothing because the users validate all the transactions themselves. It's an ideal, decentralized approach. To explore this possibility, we've built an IOTA charging station prototype where you can use IOTA to pay and charge. No need for a card or subscription. When connecting cars, solar panels and windmills to the IOTA network, all these devices will be able to sort out the transactions and their related payments themselves. It's easy, safe and reliable. Exactly what we need to live in tomorrow's smart charging world. Join us in further.
So that video gives you a bit of an idea about the ways in which interactions with the car that you own might happen in the future. So instead of it just being a vehicle that takes you to and from work, it actually is able to capture and store energy and be able to pay that back out to the grid for value that it can get in its own wallet. And so this is a different way of thinking about a vehicle, which is quite interesting and quite unique, and I think will become a lot more common in the future. We can continue with the examples by looking at the vehicle side of that equation. So the Eli and L built a smart charger that allows for payments to be received, and you can it'll send you electricity for that. But on the other side, you need to think about how the vehicle itself will be able to, do the payments. So Jaguar Land Rover have integrated into their latest vehicle an IOTA wallet, and so this allows the device itself, the vehicle, to be able to make these transfers and pay and receive payments for certain activities. And so we'll look at a short video again that demonstrates how a vehicle will be able to interact with the world around it, receiving and sending payments as it goes. Oh, sorry about that. Let me present again. So hopefully that was also illustrative in terms of how you would be able to have a vehicle interact with the world around it. So not just thinking about electricity anymore, but thinking about the toll roads and the ways in which it pays for those things, pays for parking and charging, but then also receives payment for things. So you could think in the example here, it said that it was receiving payments for seeing that there were issues in the road ahead and sending that off to the local municipality. Instead of having to send out surveying crews to see how the conditions of the roads are, you could use the data that's captured by vehicles. And you could use that in terms of the transit on different highways, seeing the wear and tear on them and things like that. And then the cars themselves will be able to receive payment for that. So by way of giving the vehicle a wallet, you actually subsidize the use of the vehicle by allowing it to provide services to other entities, not just the owner of the vehicle and the driver of the vehicle. So this is all quite nice, and it would be great if our car was able to earn money for us and be able to do all these different things. But how do we actually get there? How do we come from the present day where we have developing technology, distributed ledgers, and IOTA, and these ideas where we want to connect everything together and be able to have a kind of a world where everything works in an efficient and seamless way. So the problem is quite hard in the sense that it's a chicken and egg problem, right? You're trying to figure out which one comes first. And so on one side you have the widespread integration of the technology is required, so for it to be useful. So you need to have toll booths that accept IOTA, and you need to have vehicles that have an IOTA wallet in order to be able to do these valued transfers. And the more of these that you have, the more useful it becomes as a part of the vehicle. And then on the other side, you have a lower incentive for people to actually integrate these technologies into vehicles and into toll booths, because not many of them currently exist. So you have both sides of the equation where you need to have both of them kind of happen at once in order to get it to become mainstream. And so that's what we're doing at the moment. So we are, so the IOTA Foundation is a non-for-profit in Berlin, and we develop this technology, this distributed ledger technology, and work with these companies that we showed to be able to help integrate and show how value can be created not only for the consumer, but also for the end user and the businesses that are involved in it. And so we're working on all of these different use cases, not just in mobility and energy, but looking at supply chain, e-health, various other areas that will benefit from having this kind of value and data transfer system in place. And so we have, you know, a number of employees. We have about 100 employees around the world. You know, we have a very, very active community working on the technology and interested in its progress, as well as we have a lot of funding available for open source projects and things like that. And so we're really driving alongside these visionary companies to be able to have this future where everything's connected and is able to interact with each other. And so as a part of that process, what we do is we also have these contests. So we have the Machine Money Hackathon, contest on Hackster that we have at the moment, that this webinar is a part of, but we also have had the previous one, which was the Smart City Hackathon, where we had, you know, various different companies come with various different problems in mobility, in energy supply, in smart districts, and also smart buildings. And we proposed to you, the Hackster community, these problems, and you came up with all these wonderful solutions about how we can integrate you know, data and value transfer into the context of a smart city. But what we're looking at this time is something a little bit broader. We're looking at how we can integrate payments into, you know, kind of everyday things at the moment, and various products that we currently have. So what we're really looking for in this contest is to have existing hardware integrated with payment functionality. So we're interested in seeing devices, you know, whether this be like a small microprocessor or Raspberry Pi or something like that, being able to receive a payment from a person, being able to pay another machine, or being able to pay a human. And so these are quite interesting concepts when you think about it. Like, you know, when have you ever had a machine be able to pay you? So you could, with these technologies, you can do micropayments. So you can think about a machine, you know, sitting in a train station that accepts, you know, PET bottles, plastic bottles. And instead of it just, you know, being a recycling bin, what it can do is that it can actually incentivize you to do those payments. So you know how sometimes, or at least in Australia, you have a little thing saying 5 cents redeemable for each bottle that you bring in. Why don't we share that out so that there's multiple points that you can bring those bottles to, and you'll receive a payment in order to do so. So you give the bottle to the machine recognizes it's the correct type of bottle, and then pays you a couple of cents to your account for doing that. And you can think about, you know, devices devices paying other machines. So you can think about the energy grid example. And there were some really, really cool concepts that were brought out in the last contest, where we had this group make green certificates, which is basically the ability to track the generation of electricity and be able to publish information about that. And so in the process of producing that energy, they could also then sell that off to another device, and another device could pay them for that. And then also the last one, in terms of receiving payment from a person, you could think about something like the EV charger that Elad and El built, where you're able to just pay tokens to the machine, and the machine would give you electricity in return. And so to kind of give you an example, I actually built a small kind of demo that you guys can see on the Hackster website, which is an espresso machine that I hacked together to accept tokens. So this is an example of a human paying a machine, where I added an e-ink screen to the front of it and wired it into the device. And when you want to get a coffee, you just scan the QR code, send a payment to it, and that will dispense a coffee for you. And so with this, I was kind of easily able to demonstrate how you were able to take something that isn't particularly wired for payments or created for payments, but then you could integrate, you know, a device into it, which would allow for that to happen. And so if you check out the Hackster website, which we have here, you can see the page that I created, where we have an example of, you know, it actually receiving payments and dispensing coffee, and it goes through kind of the production process, and I have the code examples, as well as the 3D files that I created for the thing. In terms of another example that would be useful to look at, you could also see the next project that I'm going to embark on. So I'm going to basically enable this open source charging hardware that you can buy on the internet, and I'm going to integrate like the Elad charger that I talked about before. I'm going to integrate a system that allows you to do payments directly to it, But then taking it a step further, I'll allow for another machine. So if we can emulate a car wallet, the car will be able to talk to the charger and then request payments and negotiate payments for electricity. And so this is something I'm quite excited about, and I'll make sure I post another hackathon project, Hackster project, so you're able to see it. But so those are two examples that I'm interested in and that I want to build. But you can think about some other ones that might be useful for you to think about for the contest. So you can think about, like, ride-sharing scooters. They exist at the moment, but they're kind of annoying to use if you've ever used them. So you have to download the app. You have to load up like $10 worth of money in order to take a $1 trip, which can be frustrating sometimes. So if you want to have a one-use or a two-use trip with a scooter company, you have to load more money than you need to be able to use it. And then if you're in a city like like Madrid or something like that, where they have like 5 different companies, you have to have each app for each company, and then you have to load $10 on each of those apps, and then you might take 1 or 2 rides, which only amount to a couple of dollars. So you have like $15, $20 that's locked up in all of these apps that you'll never actually use unless you live in those cities. So an idea could be to, if you have a scooter at home that you want to maybe destroy or modify, you could add a screen to it and allow for the device to receive IOTAs. So you pay, a couple of dollars to it, and it will run for a couple of minutes or something like that. I think that'd be a really cool project, and I'd like to see, how it's actually done, and also it'd be an interesting use case that could be, continued with. Similarly, like a parking scenario could be quite cool. So registering the number plate of the vehicle, and then letting the car in, and then when you want to leave, it calculates the payment, and then you have to pay with tokens to get out. I think that's a quite simple and easy use case. And then also looking at the recycling bin example that I used earlier. So there's lots of different things that I can think of that would be quite interesting, and you don't have to do those ones specifically. I think there's probably quite a few different ones that could be interesting when you think about doing small payments or doing payments that would allow for devices to have more utility. That's quite good. But if you're looking for more inspiration, you can actually check out our Hackster project page, where we have all of our IOTA projects, which is Hackster.io/IOTA. And you can see all of the winners from the previous contest, and also some other ones that have been added in the meantime. And it's a really good resource, and you can see how the development process goes and things like that. But in order to actually get IOTA integrated into these devices, we have tutorials for a number of different ones. We have Raspberry Pi examples that is basically the most flexible, where it's a full Linux computer that's running like Debian, and you can have all of these different tutorials in the tutorials to run either Node.js or Python or all of these different client libraries that we have, and you can integrate with that using the GPIO to do some activity outside, like whether that be lifting a boom gate or whatever. We also have some tutorials that are coming out for the ESP32. So we have a wallet for that in C, where you're able to create payments, send payments, and receive using addresses. And then we also have some examples for the Nucleo, STM32 Nucleo from STM. And so I can link all of these tutorials in the description. That'll be posted in the discussion page of the Hackster contest. But apart from those specific devices, we also have just a bunch of different workshops. So these are workshops that'll take you from like Hello World all the way to generating transactions, as well as listening for live MQTT streams for different transactions, so you can trigger certain actions and things like that. And so we have these for JS, Python, C, and I think Go. And you'll be able to interact with those, and they're up on GitHub, so you can see them. And again, I'll post a link so that you're able to interact with it like that. And then there's a few other areas that you can go to for resources. So we have our documentation site. Again, link will be posted after the video. We also have live streams, which are usually quite good. And so there'll be another one next week, I believe, going through integrating IOTA with hardware devices. So a bit more technical than this. This is more about the ideas and introducing you to the concepts. But this will be kind of an hour or 2 hour long live stream where goes through and looks at, how to integrate IOTA with a specific device. And then we also have a backlog of all of these, which are on our YouTube channel. So if you want to go check those out and learn a bit more about it, we have a bunch of different topics that you can have a look at and play with. But yeah, thank you very much for listening. That's the end of the presentation. I hope it was interesting, and if you have any questions about any of the concepts that I raised and would like any kind of deeper information, I'm happy to answer them in the Q&A section, which will happen after this. But yeah, thank you for listening, and looking forward to answering some of your questions.
Hey, Lewis, if you want me, I can read the questions to you. We have a couple in the chat panel. And anybody else who has questions, please ask them in the QA panel. So we have one from Sarab. He asks, is IOTA supposed to be completely isolated in the device ecosystem? How is IOTA converted from human currency to the one used by the devices?
Yeah, so that's a very good question. So IOTA has its own kind of like value, and it fluctuates, on a daily basis. You could think of it kind of like a normal currency, like a euro or a US dollar. It varies relative to others. But there are ways in which you can go and you can purchase it. So just like you can purchase euros or US dollars on an exchange, there's a similar type process for the cryptocurrencies like IOTA and others. And in terms of being able to purchase them programmatically, I think there's going to be some options to do that in the future, where you can, have devices settling into US dollars from IOTAs and things like that, which would be really, really useful in order to have a lot more stability in terms of the transactions that you do. So hopefully that answers your question.
Great. We have another question. Beth Majola asks, is IOTA available in other countries?
IOTA is available. So given that it is a distributed ledger, it's distributed in the sense that anyone in the world can use it if they want to. So all you need to do is find a public node, and you can basically start programming and write some code to interact with the servers. If you want to just play around with it even a little bit less technical, you can just download the wallet and you can start sending transactions on the network. But in terms of being able to work on the contest, we have a faucet available. So it's just literally like a website you go to, you put in an IOTA address, and it gives you testnet tokens. So it gives you some small tokens to play with. And that's, it's basically like exactly like the main network where all of the value is transferred. But it's just a mirror image that has no value, and we hand out tokens so people can develop on it without the risk of losing any funds if they write the wrong code. Sorry. Yeah. Are there any other questions? Okay. No worries. So in terms of there being a replay of this video, yeah, there will be, this is being recorded, so we'll upload this after the webinar's over, if that's correct.
Somebody asked, wait, somebody raised their hand. Oh, looks like it's gone. If you have a question, ask it in the QA panel, please.
But I'm quite excited to see the response in terms of the projects that people make. But if there are any questions, not in terms of like the webinar right now, but if you have any questions in terms of, I'm having some problem with this, or my code isn't working like that, we have a large community on Discord where everyone can come in. We have hardware channels, we have channels for each of the different languages with our client libraries, and you'll be able to go in there and ask some questions and get some help if you need to. And we're always available on the Hackster discussion page if you also want to ask as well. So if you don't have any questions right now, but you might have some in the future, don't worry, we'll be able to answer them as well.
Great. All right, thank you so much, Lois. If anybody else has any questions, I guess we can. Wait, there's one more question. Okay, how the government will react to this model of financial transactions?
Yeah, so this is a really good question. It's kind of it's a hard one because every different country has different fiscal policies. So having these kind of supranational, like above the national level type value transfer tools is something that governments are looking at very, very closely. So you've heard kind of the name Bitcoin and Ethereum and IOTA and the other ones kind of shared around in the news. And they're trying to figure out the right way to do this because it's a really good new technology. As I described, it's quite, if you look at the old financial infrastructure, it's quite old and clunky and costs a lot. And there's this new technology which offers a lot of promise, but it has to be regulated correctly. So governments around the world are looking at how to make sure that it isn't abused and people don't lose money and things like that. But on the other side, they don't want to try and stifle it and stop the innovation from occurring because it really can enable a lot of interesting things. So in order to answer your question, I think they're reacting cautiously, or at least I hope they are, because if they have a knee-jerk reaction, then it can stop the progress that we're working so hard on. And if they don't regulate it at all, then I think people might be a lot warier of it because some people might lose their money and there might be more hacks or something like that.
Great. Titus Tobias asked if we have a handout or slides or further resources, and we do have those, right? And I'll send those out afterwards. I'll send everyone the slides, and the recording will go out after it's edited and uploaded.
Great.
Anyone else? I'm really excited for this contest and see what everybody's going to make. I kind of want to join myself. I can't win, but I'll just.
Yeah. No, well, me too. Like I built the Nespresso machine because I hadn't been building things for a while, so I'm kind of a little bit sad I can't enter because I'd hope I'd win, but
it's a really good project.
So I can't. So, but anyway, yeah, I'm excited to see what everyone comes up with. It'll be quite cool.
Yeah, and you guys can use like the discussion board for brainstorming and asking questions. So head over to the contest after this and start working on your projects. Cool.
Great. Yeah.
Okay, I think that's about it, I guess. Thank you so much, Lewis.
Yeah, thanks for having me. And yeah, I hope this was an informative session for everyone who was watching.
Great. Have a great day, everyone. Thanks for attending.
See ya.
Bye.